Let's begin. So welcome everybody. We're on to 2A.2 today, and we'll do it over two parts. We'll start very easy, and then it will get a little bit more complex, okay? What we're going to do is we're going to start by just performing the square root of a number. So we're looking at this kind of equation. If we have x squared equals k, we're trying to get x by itself. What we're going to do is perform the square root of both sides, because when you square root a square, they get rid of each other. And so we would have x is plus or minus the square root of k. Alright, so that's like when we say, for example, the square root of 25, it's not just 5, it's plus or minus 5. Now the reason that's the case is because positive 5 times positive 5 is 25, and negative 5 times negative 5 is also 25. So when we square root, we have two solutions. Okay, so that's just a recap of that. Now, even maybe before we start this, I want to show you how we can use our calculator to support us. Our calculator is our friend. So can we pull those out? And just in the run mat, in your main calculator setting, we go to option. So in the main setting, option, press calc. So option, make sure this is right. That's option. So option is next to the shift button in the second line. So it just says OPTN for option. So we go option, calc. All right, and then, so we press option, calc. Calc corresponds with F5. And then where F5 is again, we have solve N. Solve N. So we're going to press that one. And it's popped up with a bracket like this, solve N, with an open bracket. Now what we're going to do is type in the equation that we want to solve. So we want to solve this equation here. So what we'll do is we'll type it in. So we're going to type it in brackets, x plus 3 squared. Right, just float around, make sure anyone's got any questions so far. Okay, then the way we bring up equals is it's at the bottom where the full stop is. So we're going to press shift and then the full stop button. Shift and then the full stop. And that's going to bring up equals. And we're going to make it equal to 7. Okay, but there's a couple more things we need to do. We also need to state the variable that we're solving for. So we put a comma, and the comma is under the cos button. Why? Does anyone know why it's there? Cos. That's where it goes. So we'll go comma, and then we're going to put x. Okay? So we've got the equation, the comma, we're solving for x, we close the bracket, and then we press execute. It will say something about more solutions existing or many solutions exist. We just press exit and it's going to display our solutions. So the answers are minus 5.6 and minus 0.35. Okay, right? So these are the irrational solutions. We're going to find them exactly. I might write them up here for now and I'll show you how we're going to find them exactly. Where to go? Here. So what is that? Minus 5.645 and minus 0.3542. Now what I do whenever we're writing an answer down, I'll always write 4 figures. Okay, 1, 2, 3, 4, and then we round the 4th figure. That gives us what we call 3 significant figures. Okay, same over here, we've got 4 figures. The 2 rounds down, so minus 0.354. Alright, so those are the solutions that we've rounded, but we're going to find them exactly using this algebraic process. Okay, so here's what we're going to be doing for the first part of this exercise. We have x plus 3 in brackets squared is 7. The first thing we're going to do is square root both sides. Alright, so we're going to square root here and the square root here. On the left-hand side, that's going to give me x plus 3. And on the right-hand side, we're going to have plus or minus the square root of 7. So on the left-hand side, the square root and the squared have cancelled. On the right-hand side, we know that when we square root a number, we get the positive answer or the negative answer. Okay? Then if we're trying to get x by itself, all we're going to do is take away 3 from both sides, right? So we're going to have x is minus 3 plus or minus root 7. Alright, so I've moved the 3 over to the other side. Now this is actually both of our solutions that we've got here. If we have minus 3 take away root 7, if you type that in your calculator, you're going to get exactly this. And if we have minus 3 plus the square root of 7, we're going to get exactly that one. The difference between these two answers is just they're expressed differently. Here we've rounded it, so it's not as precise. Here, it includes every decimal place that goes on. So it's what we call an exact answer. All right. Now, in these equations, we want to solve them exactly. I just wanted to draw it away. You can use your calculator. You can use this any time to solve any equation. All right. So that's a good recipe to know. All right. Let's move on to the second one. All right. So we'll start by square rooting both sides. We'll have x take 2 is plus or minus the square root of minus 1. And straight away we encounter an issue. Does anyone know what the issue is? Very good. Excellent. We cannot square root a negative number, which means this equation has no solutions. Whenever we try and square root a negative number, we get an error. There's no solutions to this equation. There's no values of x that make this true, so we're going to write no solution. Now that will pop up in the textbook today. They'll try and get you to square root a negative number. When they do that, you say, no solution. There's no values of x that make it true. And you can even try by typing that into the equation solver if you want to. All right, over to example C. We have 2 times x take 3 squared equals 9. Now, before we get rid of the squared, we need to divide both sides by 2. We need to get rid of that 2 out the front. So I'm going to divide both sides by 2. On the left-hand side, it will cancel. And so what we'll have is we'll have x take 3 squared is equal to 9 on top of 2. All right? We could write it as 4.5. It doesn't really matter. Generally, the convention is we leave things as an improper fraction. Next, we'll do exactly what we've been doing. We'll square root both sides. Now this can simplify using surd operations, but we don't cover them till semester 2, so we're just going to leave it like that for now. And then again, we've got x take away 3. The way we're going to get rid of that minus 3 is by plussing 3 to both sides. And so that's going to be our answer. We have 2 solutions. 3 plus the square root of 9 on 2, and 3 take away the square root of 9 on 2. Okay, that's enough for us to do 2A.2 question 1. We won't spend long, I reckon at the most 10 minutes, and then we'll come back and go into the next part, which will be a bit trickier. All right. So, what we'll do is we're just going to have a quick recap of the perfect square rule. Then we'll have a read of our process, and then we'll get into these examples. So the first perfect square rule that we learned is this one. If we have a plus b times a plus b squared, this is the formula that it expands to. Now, we're getting to a stage where, especially if you go on to do 12 methods, that's something you'll need to know off by heart. Okay? That's when we have a positive, and we also have the circumstance where we have a negative in between. Alright? Both of those are called perfect squares. Now here's an example, like if we have x plus 3 squared, well the x corresponds with the a. So we would have x squared. Then we always have 2 times a times b in the middle. So 2 times x times 3 in the middle, and then plus b squared. Alright, now 2 times x times 3 simplifies to 6x. So it could be expressed like this. This is a perfect square, and so if we are to factorize it, we can recognize it can be written like this, and if we see that, we can factorize to here. That's a tool that we're going to use today. Similarly, when we have the minus, alright, all that's doing is changing that symbol there to a minus, but it stays the same. A squared, 2ab, b squared. So here, again, x take 4 squared, we'd have x squared 2 times x times 4 plus 4 squared. Okay, let's have a quick read of the process that I've given you at the top of page 3 we're on. 5 even, sorry. Top of page 5. Process. Okay, this is the skill we're going to be solving now to solve these equations by completing the square. Rearrange so that only the constant term is on the right-hand side. Okay, now the constant means the number by itself. That's going to be our first step. In our first example here, we can already see the constant term is on the right-hand side, so we don't need to change this one. Over here, we're going to need to move that number over to the left-hand side. Okay, we can't do it at the moment, we will need to do it over here. All right, so move the constant to the right-hand side. Step 2, complete the square by adding b divided by 2 squared to both sides. Now I need to explain what b is. When we have a quadratic, generally it takes this form. This is called the general form of a quadratic. All right. Now a is the coefficient of the x squared term. B is the coefficient of the x term. So all we're doing is going, what's the number in front of the single x term? And we're adding that divided by 2 squared to both sides. Okay, let's apply it. So, for our first question here, this is not A, by the way, we're up to question D, aren't we? Sorry, that is D, E, and F. D, E, and F. Good. So, x squared plus 2x equals 5. Step 1, rearrange so that only the constant is on the right-hand side. Done. Step 2, complete the square by adding b divided by 2 squared to both sides. Now in this circumstance, b is the coefficient of x. So in this circumstance, b is positive 2. So what we're going to do, we're going to add, alright, I'm going to write it in blue. We're going to add b divided by 2 squared to the left side. Because we've added it to the left side, therefore we also need to add it to the right side. Alright, so we have an equation. We can do anything we want to an equation as long as we do it to both sides. Alright, so we've added this to both sides, we've maintained the equality. They're balanced, they're still equal, right? Now we'll simplify it a little bit. Alright, so we've added it to both sides, that's fine. I've drawn out the colour, and I'll just say the coefficient here is 2, so we have 2, that's the value of b, always divided by 2. The number at the bottom is always going to be 2, this number at the top will change, always squared. Alright, now I'm going to write it like this. This is not an essential step, but I'm just going to try and draw this out for you. What we have here is 2 times x times 1 plus 1 squared. Alright, over on the right hand side we'll have 5 plus 1 squared. Now here's the connection that I want to make. We're completing the square. We're making it, we're manipulating it and forcing it to be a perfect square. Look at this, we have a squared plus 2ab plus b squared. Okay, it matches the perfect square, and of course that's the case because we've forced it to. So that means on the left hand side, we're going to move from here, from the perfect square, back to here. We're going to write it as a plus b squared. In this circumstance, x plus 1 squared. Alright, we're going from there to there. This will always be the case because we've forced it to be that way. Alright, understand this is tricky, but we've got a couple of examples to help us through it. Over on the right hand side, we just have 5 plus 1, which is 6. And then we're away to the hills. We're just doing what we did in question 1. We're going to square root both sides, plus or minus, and then we'll move the 1 over. Okay, on to E. We have x squared plus 6x equals 2. The constant term is already on the right-hand side, so nothing for us to do there. Our next step is to add b divided by 2 to both sides. All right? In this circumstance, b is positive 6. All right? So we're going plus 6 divided by 2 squared to the left-hand side, and then we will do it to the right-hand side as well, won't we? All right. We'll simplify it a little bit. 6 divided by 2 squared, that's going to be 3. Over on the right-hand side, 2 plus 3 squared. Okay, so again, we're forcing it to be a perfect square. I've written it out like that, so we can see a squared, 2 times a times b plus b squared. Okay? Now, that's going to become x plus 3 squared. On the left-hand side, we're factorising it. We've completed the square. We've forced it to go to that. And on the right-hand side, we're going to have 2 plus 9. 2 plus 9 is going to be 11. Okay, and then we're away. Square root both sides. Take 3 from both sides. All right, so from now on, I think we seem to be hopefully we're okay with how that's a perfect square and how we're going to simplify it. Let's move on to our next example. Step 1, move the constant term to the right-hand side. So we're going to have x squared plus 5x is equal to minus 2. That's our first step. We've moved the constant term. We've taken 2 from both sides. We've moved it over. All right, our next step is to add b divided by 2 squared to both sides. So we're going to add that divided by 2 squared to both sides. So we'll have x squared plus 5x. And then we're going plus 5 divided by 2 squared. And over here, plus 5 divided by 2 squared. All right, now, on the left-hand side, we've got a squared. Here we've got 2 times a times b. We don't need to write it out like that every time. We can go straight from here, and it will always go to a plus b squared. All right, there's b. We can see both of them are squared, a plus b squared. The same over here, all right? Here's a, here's b, a plus b squared. Here's a, here's b, a plus b squared. All right, so we don't need that intermediary step. There I'm just trying to draw out the completing the square. All right, and 2.5 times 2.5, that's going to be 6.25, I think. Let's check. Can I put this? I'm not sure where I put mine. 2.5 squared, 6.25. So we have minus 2 plus 6.25. I'll do it slowly. On the left-hand side, x plus 5 on 2 squared. On the right-hand side, when we add those together, we have minus 2 plus 6.25. That's 4.25. All right. So that's all good so far. And now we're just repeating what we've been doing. We square root both sides. Plus or minus the square root of 4.25. And then we'll move the 5 on 2 over. All right, so a little bit more confusing, that one. So it involves a fraction. We've got a decimal here. That could be expressed as a fraction as well. It doesn't really matter. So what have we done? We moved the right-hand side term over. We completed the square. We square root both sides, and we obtained our solution. All right, on to G. Here's some room. Now G we have is x squared take 4x plus 1 equals 0. All right, step 1, move the constant term over to the right-hand side. Step 2, we're going to add b divided by 2 squared to both sides. So that's going to give us we're going to have negative 4 divided by 2 squared here, and negative 4 divided by 2 squared here. Now, negative 4 divided by 2, it's going to become, let me write it out like this first. It'll be minus 2 squared. There we go. Alright, it's minus 2 squared, which when you minus 2 times minus 2, that will become positive 4. But notice here in this circumstance, we have the negative. This is how this one's a little bit different. We have the negative case. Now, so far we've been exploring the positive case, but when we have a negative there, or we have a negative b term, alright, it's going to factorize to a take away b squared. Okay? A take away b squared. There's a couple of ways to see it. Firstly, we'll always have a negative in the brackets here, and secondly, we'll always have a negative b term. Whenever there's a negative b term, that's going to be a negative in the middle. Alright, over on the right hand side, we have minus 1 plus 4. So this gives us x take 2 squared is 3. Square root both sides, and move the 2 over. Alright, so I'm going quickly over that last stuff, but I think we're comfortable with that process. It's the earlier part that's a bit tricky. And for our last one here, h, this one's a little bit different again because we have a 3 out the front. We have 3x squared plus 6x equals 4. Now, whenever we have a number out the front and we're solving an equation by completing the square, we're always going to get rid of that 3. Just answer this quickly. Hello, Jonas. Good, thank you. No, he's present. Yep. All right. Sure. Yep. All right. Okay. So back here. So whenever we have this number out the front, we need to get rid of it first. That's the very first thing. So we're going to just divide both sides by 3 to get rid of that 3 out the front. We're maintaining equality. All right, we're dividing both sides by 3. And over here, we're just going to have 4 on top of 3. It's not the most pleasant constant, but it's a perfectly suitable solution. Okay, now let's check where we're at. We've got the constant term on the right-hand side. We don't have a coefficient here anymore. We've gotten rid of that. We're ready to complete the square. So we're going to add b divided by 2 squared to both sides. All right, so b in this circumstance is 2 again. So we have 2 divided by 2 squared. All right, before we complete it, I'll just simplify that a little bit. Now over here we'll have 4 on 3 plus 1. Okay, so this is ready to complete. It's a perfect square. We have a squared, we have b squared. It goes to a plus b squared. On the right hand side we have 4 on 3 plus 1. Now just a refresher for fraction operations, you can type it in your calculator, but what we want to do is we want to express 1 with the same denominator as that. Alright, so one way we could do that is 3 divided by 3. They have the same denominator, so now we can add the numerators together, 7 on 3. That's how we add fractions, right? They must have the same denominator. So on the right hand side, we've got 7 on 3. Square root both sides. And then move the 1 over. Gorgeous. Alright, so that's enough to complete the rest of 2A.2. That's where we're dedicating our time today. So let's have a good old wrestle with this exercise.